Hey everyone, in this video I'm going to show you how to use the Desmos geometry tool to graph perpendicular bisectors and in turn help us find the circumcenter or the point that is equidistant from all 3 points of a triangle. Okay, so to start, hopefully you have already clicked on the link that I provided to go to this page that I've already set up. And on here I have a map of St. Louis over here and a point locating where St. Louis is, a point for Kansas City, and a point for Des Moines, Iowa. So the first thing I'm going to do is I'm actually going to create the triangle so that we can see the triangle in action. So here I'm going to click on the segment tool and we're going to choose segment. All you do to make a segment is you'll click on this first point for Kansas City, click on this point Des Moines, and there's your segment. We'll do that for Des Moines and St. Louis, and then lastly for St. Louis to Kansas City. So now we have our triangle. Whenever you're done constructing something, it's always helpful to click the arrow tool just so you don't end up clicking more things and creating more segments. Now it is time for us to create our perpendicular bisector. Now a perpendicular bisector by definition is a line that is perpendicular to a side of the triangle, and it is also bisector, meaning it's going to go through the center, aka the midpoint. So that's what we're going to do first. So the first perpendicular bisector I'm going to create is between the cities of Kansas City and Des Moines, Iowa. So we're going to start here. So to construct the midpoint, we're going to click on our point tool, and there it is, midpoint. I'm going to hover my mouse over the segment that I created. Notice how when I moved my mouse, it automatically moved to where it was. So that is directly between Des Moines and Kansas City. I will click it. My midpoint has been created. Second step is we're now going to create a perpendicular line that goes through that point. If we click on the segment tool here in the center, you'll see that there's a button that says perpendicular. What's really nice about Desmos is at the top, it tells you what to do. So the first thing it says is choose a line to be perpendicular to. So because I am trying to find the perpendicular bisector between Des Moines and Kansas City, I'm going to click on that segment. The next question up there says choose a point to pass through. So I'm going to move my mouse over to that midpoint. And right there, do you see how it snapped when I was moving it? So I'm moving my mouse around and boom, it snapped it in place. So I will click it. And that line that I just drew right here is the perpendicular bisector between Des Moines and Kansas City. We're going to repeat this process for the other two sides. Now, technically, you only need to do to one other side, but since it's just a lot of clicking, we're going to actually do it for all three. So I'm going to press the back button up here to go back to our main screen. And we're going to go ahead, and this time I'm going to find the perpendicular bisector between Kansas City and between St. Louis. So I start with my midpoint tool. So I'll click midpoint. I'm going to select Kansas City to St. Louis. There's the midpoint right there. And then we'll create our perpendicular line. So I'll click perpendicular, choose a line to be perpendicular with. I'll choose that bottom triangle. We'll move my mouse so it snaps to the midpoint, and there it is. I'll go ahead and click the back button, click on my arrow tool, because I want to show you that we've actually already found the intersection. So right there, that point right there is equidistant from Des Moines, from Kansas City, and from St. Louis. But just to be safe, and since we're sitting here, let's go ahead and find that third perpendicular bisector. So the one that we're doing now is Des Moines to St. Louis. So I'll start by doing my midpoint. I'll hover over this segment. That purple dot represents the midpoint. We'll click on perpendicular, choose the line. I'm going to choose the Des Moines St. Louis line, move my mouse to the midpoint, and lo and behold, it found the exact center. And the nice way that we've proven this is that all three of them are intersecting right there. So just to give us a pinpoint of exactly where that is, I'm going to click on my point tool. So click on the word point and just hover your mouse so that you can actually click on that intersection. If you want to find what that coordinate is, sure, we could look at the X and Y axis. It looks like it's like around 14, and over here it looks like to be about 8. But if you want to be sure, if you click on this and hit these three these three dots, you can actually click label, and it will automatically give you the exact point. So the point 14, 8.7 is going to be exactly where it is equidistant, or the same distance from Des Moines, Iowa, from Kansas City, Missouri, from St. Louis. Now, because we're here on the video, and because I have a couple minutes here still, I'm going to hide some of this stuff right now because I want to show you that it actually is going to be that case. So I'm going to hide all the stuff that we just worked on. So you don't have to do this if you want. This is really just more to prove that this work actually does find this point for us. So when I hide everything, I have my point here, which is my circumcenter. If I use the circle tool, watch this. So I click on the circle tool and I click this point and I arrow to, I don't know, pick whatever city you want. Pick Kansas City, pick Des Moines, pick St. Louis. It won't matter because when I click on one of the cities, do you see how it clicks on all three of them automatically? So as we know, a circle is always going to be the same distance from a center. So St. Louis is the same distance, Kansas City is the same distance, Des Moines in the same distance. In fact, anything that's along this green circle is the same distance. So actually, funny enough, Davenport, Iowa is actually about the same distance away from this purple point as well. So is Peoria, Illinois. Didn't know we were going to be doing a geography lesson in this video, but there you have it. All of these cities along this green circle are actually the exact same distance from here. So in terms of Amazon, this distribution center would be best served by anything inside of this circle because they're all going to be the same distance. And that will conclude how we can create a circumcenter from a triangle. Feel free now to try this on your own with the Amazon problem, or you can try it with many of the other variety of problems that I have selected for you to work on for your final assessment. Thank you for watching.